Let's review another sample question. The STEM reads, a startup company is looking for a solution to cost-effectively run and access microservices without the operational overhead of managing infrastructure. The solution needs to be able to scale quickly to accommodate rapid changes in the volume of requests and protect against common DDoS attacks. What is the most cost-effective solution that meets these requirements? Now to diagnose the question. It's important to note that the company is running microservices and is specifically looking to run the microservices without the overhead of managing infrastructure. It also states that the solution must scale quickly and protect against DDoS. One last call out for this question is that the company is looking for the most cost-effective solution. Now, time for the responses. A, run the microservices in containers using AWS Elastic Beanstalk. B, run the microservices in AWS Lambda behind an Amazon API gateway. C, run the microservices on Amazon EC2 instances in an auto-scaling group. D, run the microservices in containers using Amazon Elastic Container Service backed by EC2 instances. Now, time for a pause so you can review the question and select an answer. As usual, you have until I count down from 3 to pick an answer, so pause the video now if you need more time. 3, 2, 1. The key for this one is B, run the microservices in AWS Lambda behind an Amazon API gateway. Let's break down why this is the correct answer. First of all, AWS Lambda is a great solution for hosting backend microservices without the operational overhead of managing infrastructure, as AWS Lambda is a serverless service. So this solution meets that need. Second, API Gateway and AWS Lambda can scale up to meet rapid changes in the volume of requests without you needing to manage that scaling. The scaling mechanisms are built in and are very fast, so this meets that need as well. Third, we need to think about DDoS protection. Both services, API Gateway and Lambda, are managed services that have massive capabilities for scaling. So it's actually very hard to overwhelm these services. On top of that, API Gateway allows you to throttle for each method that you create. This makes it so that your backend won't be flooded with requests. They would instead be dropped at the API Gateway level. Also, API Gateway automatically protects your backend systems from distributed denial of service attacks or DDoS attacks, whether attacked with counterfeit requests, which are layer 7, or SYN floods, which are layer 3 in the OSI model. Now finally, the fourth point here is this the most cost-effective solution? And the answer is yes. Since both API Gateway and Lambda are serverless services, you do not pay for idling resources. So given the requirements and the rapid changes up and down in the volume of requests, you could be sure that you are only paying for what you use at any given time, not paying for idling resources like you may do at times with services like Amazon EC2. All right, now let's review the incorrect responses. First up is A, run the microservices in containers using AWS Elastic Beanstalk. This answer is incorrect for a few reasons, one being the rapid scaling requirement. AWS Elastic Beanstalk makes it really easy to host applications on Amazon EC2 instances inside of an auto-scaling group fronted by an elastic load balancer. This solution is scalable, but it can take a few minutes for the scaling to happen because Amazon EC2 instances need to boot up when a scaling event occurs. So this may not be fast enough for the requirements. The next reason why this solution is incorrect is that it is not the most cost-effective solution. Since this is an EC2-based service, resources may sit idle while volume is low, but still incur cost. This means it is a less cost-effective solution than AWS Lambda. Next up is C, run the microservices on Amazon EC2 instances in an auto-scaling group. This one is incorrect for the same reasons as AWS Elastic Beanstalk. This does not scale as quickly and also has the issue of potentially idling resources. So this answer is incorrect. Finally, there is D, run the microservices in containers using Amazon Elastic Container Service backed by EC2 instances. Now, funny enough, this is also wrong for the same reasons as the last two answers. Because the microservices would be in containers, the scaling for an individual service would be very fast. But if you have to scale the cluster, which you likely would for large changes in volume of requests, then the cluster will still take minutes to scale. This is not fast enough for the requirements. This solution also has the same potential for idling resources since it is an Amazon EC2-based service, which means it is not as cost-effective as API Gateway and AWS Lambda would be. All right, that is it for this one. If you got this one incorrect, I would recommend reading up on the scaling mechanism, DDoS protection mechanisms, and pricing for all services involved. Once again, remember this is an assessment course, so it's supposed to help you find gaps in your knowledge for you to then go do some further research before taking the exam.